Hey guys, welcome to this video. Today we're going to do Leetcode number 238, product of array except self. And like all the other Leetcode videos in this channel, we're going to do it in real time, so I'm not going to, this is like the only time I'm going to do it. So if I mess up or anything, we're not going to re-record. This is the only time we're going to do it. So the prompt here is: given an array of nums of n integers where n is greater than 1, return an array output such that output of I is equal to the product of all elements nums except for nums I. This is a really hard one, actually. I know how to solve this. I've already solved this, but it's really hard, and I'm pretty sure I'm going to mess up a few times or something. But yeah, we'll try to solve this, man. Well, this is a really hard one. So what you're supposed to do is you are supposed to basically get the product of everything in the array except for whatever number that currently is. So for example, this number, right, 24, actually 1, so you're supposed to get the product of all the other numbers. So 2 times 3 times 4 is going to equal to whatever this number is, 24. And then for the next one, you're going to do 1 times 3 times 4 to get the next number, and then 1 times 2 times 4 to get the third number, and then 2 times 3 times 4 to get the last number. And that's a really hard one. How do you solve this? I already know the solution, so I'm kind of spoiling it already, like for myself, because I already know how to solve this. But if you are not familiar with how to solve this, this might be very confusing. You can try out a few different things to do it, and you might eventually get the solution. First thing we're gonna do is we're gonna try to brute force the solution. Okay, so we're gonna brute force this. Question: how do we brute force this problem? Alright, so obviously first thing we're going to do is, whoops, my bad. First thing I want to do is I want to accidentally press Control Shift A instead of just Shift A, which I wanted to do anyway. So first thing we want to do is we obviously want to loop through it. So for I in range length of nums, okay, so we want to loop through it at least once. And we probably want to loop through it again, but the thing is, we want to skip all the numbers of I up to I and before I. So, or we want to skip the I itself. So we can do another loop, I guess, for j in range length of nums. So this is going to be a brute force solution. Like it's not going to be good at all, and I hope you guys, I'm acknowledging it's not going to be good. I want to do mult, I guess. Maybe. Should I do that? Maybe not. I'll just create an array here called result, and then we'll equal it, make it blank. Let me go ahead and zoom in over here. Okay, so I'll have an array called result. And for I in this range here, what I want to do is I want to just multiply if I does not equal to j, if the two are not the same index, we just want to add the result. But I also want to have like a number to equal, you know, mult is equal to I. Okay, so actually mult should equal to nums I, so whatever that value is currently. So actually no, it shouldn't equal that because it should multiply by itself. So what should the mult be? It should be the first j. You know what, I'll just make the mult 1. So if I is not equal to j, if they're not the same index, we want to multiply the mult. So nums j times the mult times is equal to mult. Actually, mult, I'll put mult first. Mult times is equal to nums of j, so whatever value that is. Alright, and then at the very end of this, we are gonna do results.append mult, and then we'll just return result. And this should be the solution. I'm pretty sure this will be the solution. So let's go ahead and run this. This is like the brute force solution. So that's a brute force solution. except it's really slow. But we did it. We figured out a brute force solution. Let's go ahead and run it. It's not going to pass if we run this. You guys can see even my ultra first passes were super slow, and then this is going to be even slower. So yeah, this is going to time out like easily. When then we'll see a good solution. Okay, so do I even want to click on this? Okay, that's a lot of numbers. So it's trying to multiply all of those, and obviously ours is way too slow to check every single number there, and that's why we had time exceeded. Alright, so we did the brute force solution. Now how do we optimize it? This is the hard part, because you gotta I don't know if people can even figure this out themselves. Like, I'm not able to figure this out myself. If I just like, maybe if I spent like a few hours thinking about the problem, I'd be able to figure it out. But usually after a few minutes of trying to figure something out, if I still can't get it after trying a bunch of different things, I would just look at the solution. But depending on the person, they could be less time pressed than I am, and so they might not care, and they can spend hours on this and figure it out eventually. I think maybe they might figure it out eventually. But this is such a weird solution, in my opinion. That's not like, it's not something intuitive, just something that just comes like, it's just some algorithm that's just like there. The proof is there that it works, but it's hard to come up with it initially, I think. So the solution to this is you create two arrays. You create a left array. Let me just call it left to right. So left LTR. Okay, so there's one array that's left to right, and then there's another array that is RTL, so right to left. And then we're gonna set these equal to nothing for now. And then the right to left will also equal to nothing for now. And then what happens is we will basically just I think we multiply just all the numbers together like previously, and we just add it here. So from left to right, it's going to be 1. The first number is always going to be 1, okay? And then the second number is going to be the first number times that number, so it's going to be 1 again. And then this third number is going to be the second number times the previous number, so 2 times 1 is 1. So this is 1. This is going to be 2. I mean, 2 times 1 is 2, not 1. I kept seeing 1, so I just said 1 out loud. But yeah. So then this last one is going to be 3 times 2, and then that's going to be 6. So that's going to be the left to right table, and then the right to left table is now going to go the opposite way. So the way I was doing it earlier, I was going down this way. Now we want to go down this way. So we want to start off on the right side first. The right side value is always going to be 1 first here, and then we want to do 4 times 1, so this is going to equal to 4. And then we want to do 3 times 4, that's 12. Okay, and then we want to do, whoops, that's 12 there. And then what we want to do is we want to do 2 times 12, so that's 24. Okay, so now we got the left to right and then right to left arrays here. And then to get this final output, you just multiply them one by one like this, like 6 times 1. Okay, let's do that. I'm going to go left to right again, so I'm going to put an equal sign. 1 times 24 is going to be 24, so we'll put that down. 1 times 12 is going to be 12. Okay, and 2 times 4 is going to be 8. Okay, that works. And then the last one is going to be, my bad, 6 times 1 is going to be 6. What the heck is this thing? This is 8. I was like, what is that number? I was so confused for a second there. I was like, what is that? That's weird. Anyway, that's an 8, I think. And yeah, so you guys can see this solution is equal to this solution here. And I don't know if people can even come up with this method, like just thinking about it. Like, is this possible? You just come up with a solution like, okay, let me do the left to right and then right to left. Is that something you can just come up with on the spot? Like, to me, I don't know if I can come up with a solution like this. I had to look it up to get the answer, because I don't think there's a way. Even if maybe if I spent like hours and hours just thinking about it, I'd come up with this left to right, right to left thing. But for now, it's like there's no way I can do that. So that's the solution, guys. Now we'll try to put it in code. If you want to try it yourself, pause it and then try doing this yourself. You guys know the method. You guys just need to try programming it. So do it like that. Okay, so now let's go ahead and do this. I'm going to delete everything that we had before, and I guess we will need a result, but for now it's just going to be empty. And so we're going to create the left to right. So left to right is equal to that, right to left is equal to that. And we want to put in the number 1 because, like I said before, you guys start with 1. Like that part to me just already makes me lost, because I would never have started the arrays with 1, you know. They both had to start with 1 each, okay? And now what we're going to do is we're going to iterate from left to right for I in range length of nums. We want to go from left to right, so LTR.append. We want to append this number times the previous one, so we can just do nums I. And I think we actually want to start from the first element only, because we only want to do up to, yeah, we want to start only from the first element because the first element is already stored there. I minus 1 times LTR of I. And I think that's what you're supposed to do. Let me go ahead and print this out. Print LTR, and just so we can see if this is even correct. So I'm gonna just run this code and see if it's correct output. So we go down here, list index out of range, I minus 1 LTR times I. Why is that? For I in range. Oh, okay. This I think is LTR I minus 1. This one should be I. Okay, so that's where I messed up. Okay, so they should be swapped like that. Now let's run this again. And this is the output 1, 2, 6, and 24. Is that correct? Left to right. No, I don't think that's right. It's supposed to be like 1, 1, something. Let me. It's 1, 1, like 2 and 6 or something like that is a solution for LTR. Let's see where I messed up here. Let me try starting from like the 0th index. So LTR.append nums I times LTR I or something. Would this work? Or maybe you go up to this length minus 1. You go up to the very end. You go from the beginning until close to the end. Let's see if this works. It'd be 1, 1, 2, 6. Okay, we got the solution now 1, 1, 2, 6. And yeah, that's how you do it. You do up to the last number, like right before the last number, and then you stop. Okay, so that's the solution there. So we got the LTR table. Now we need to get the RTL table. Alright, so RTL is a bit more complicated. Well, not really. We're doing it the easy way for now. We'll show you guys the more hardcore way to doing this later, and that will be a bit harder to do. So so RTL. Now we're gonna go in like the opposite direction for I in range. This maybe I should call it J just because we're going the opposite direction, but you know it's a separate loop as well, so it doesn't really matter. For I in range, and then we're gonna go this time from the length of the nums up to 0, I think. I don't know. I mean, I'm not sure if this is gonna be correct yet. We're gonna step -1. Okay, so and then we're gonna kind of prepend instead of append. So we're gonna do RTL is equal to nums nums of I times nums of 0, and then I guess we're gonna prepend this plus RTL right to left. Okay, and I think this should work. Let me think about this again. So it's gonna go the opposite direction, and this is not correct. This is not nums 0. Do RTL 0. Okay, and now I just want to print RTL. Okay, so I'm gonna run this now, and let's see if this works. List index out of range. RTL 0 versus RTL. Nums I. Do I have to do nums I minus 1 again? I guess I have to do my RTL nums minus 1 again. I don't know. Let's see if this works. Wrong answer. So 24, 12, 4, 1. Is that correct? We're supposed to, the first one is 1, 1, 2, 6. If we multiply 1 times 24, 1 times 24, that is, yes, that's correct. 12 times 1, that's correct. 2 times 4, that's 8, that's correct. And then 6 times 1, that's 6. That is correct. So this is it. So we got the solution now, and now we're gonna do a result. I guess this time we can do it either way. So for num, like we're not really keeping track of an index or anything. Actually, yeah, we are. For I in range length of nums. I mean, we're combining both the left to right and then right to left. What we need is just a counter, basically, that just goes over the length of the entire thing. So 4 numbers. So that's why we're just doing length of nums. We also just put in length of like RTL or length of LTR here as well. Result.append. Then we're going to add LTRI times RTLI, and then that should be it. This should be the solution. Let's see if this works. So if I run this should work. Unbound unlock result reference before assignment. Okay, we referenced this variable before we assigned it, so let's go ahead and run again. This should work. Okay, so it did work, but then I think this is too slow. It's still gonna pass, but it's really slow. So it does work, but it's just a really slow solution because of prepending. So prepending makes it really slow, and we are only faster than 5.2% of the other submissions. So we're really slow here, and we can do this faster. So as you guys can see here, there's like some ranges where I have like this much, and then there's some where I have like this much. So it's like much less than what it was before. So like a 10th almost, or like a 5th or something. It's a lot. It's like 20th or something less, much less than before. But anyway, so what we'll do now is we're gonna try to do it the best way, which is like the most efficient way possible. And how you do that is you basically just you keep, instead of having 2 different tables for LTR and RTL, we're just going to have one table. So we're going to have LTR equals that, and then instead of doing RTL here, we're just going to multiply everything in the LTR, and then instead of return result, we're literally just going to delete this entire last part here, and then we're used to return LTR. Alright, so this is the super hard part, because it's really complicated. You got to do everything in place basically, and I guess it may or may not be that simple to do that. So I'm going to delete that because that's not what we're supposed to do there. So for I in range length of nums, next thing we're going to do is LTR of, I guess, let me print out what numbers we're iterating through first. So I'm going to print out I, just so I can see what I need to multiply what number by. Okay, so I need to see the index. So I'm gonna go ahead and just have that there. I'm gonna run this, and let's see what we get. 3 and 2 and 1. Is that appropriate? We also need to multiply the very last one. So we need to multiply the first one with the last one. All right, so this, I got it now. So there's actually another variable that we need to add here, where I'm going to call it right is equal to 1. That's going to be the very rightmost element. And what we want to do is we want to update the right value and store it with like the multiplication of whatever index this currently is. So for the first instance, we want to multiply 3 times, no, sorry, not 3. We want the third item here, so 1, 0, 1, 2, 3, which is 4. I guess, is that correct? It's 6. Whoops, I accidentally clicked on that, my bad. Did that mess up the solution? Okay, no it didn't. What the, okay. Let me print out the solution, the numbers I gave us again. 3, 2, 1, okay. We want to store a right variable, which is 1, and then for every, I just want to see if this is what we do. The third value, so 0, 1, 2, 3. We want to multiply 4 by 1. No, that's not right. Alright, what we want to do is we want to have the countdown basically at 2, go all the way down to 0. So I guess you want to do minus 2, and this might be negative 1. We want to do the countdown from 2 to 0 index, because we don't want to start at this location. We don't want to start multiplying it at this location. We want to start multiplying it from this location. So it's going to be this 3 times 1, I guess, and that's going to go in the next spot. Is that right? 1, 1, 2. It should be 4. Okay, yeah, I got it. So we want to start off here, but then this number is being multiplied by that one. It's being stored in the next one. Okay, got it. I got it now. So this is correct. What we have right now is correct. You just need to properly multiply things correctly. Like this is like the trickier part, I guess. You got to know which index to pick out. So we want to do right times equal to. We want to update the right value. To be, so the first one, it's going to, starting from, we want to iterate through the LTR table. What we're going to do is we're going to iterate through the LTR. We're going to start at the second, this location, the second index, which is going to be right here, because we want to skip the first one. It's just going to be a 1. So we're not going to multiply that by anything. We want to multiply this next number by the, like this number 3 here. Well, this is not number 3, but we will multiply this number, the second element, second index, with the fourth or with the third index of the other one. Okay, so nums current I is going to be 2. Nums times equal to I. Okay, let's try this, and then let's do LTR. LTR of I want to target this element of I times equal to right. But is this right? Oh, is it plus 1 then? I don't know. Maybe let's just run this. Let's just run this and see if this works. That works. Like, okay, that does work. I didn't know it was going to work, but apparently this is the solution. So it's kind of hard to think through all those steps sometimes. I'm just like, okay, this is correct. Kind of hard to put into words and explaining what I'm doing, but apparently this is the correct way to do it, and we got it. So we're only 8.7% faster. I don't know how we are any slower than the other one. This is like the optimal solution, I think. So if I go to this solution here, I can see which ones are faster than me, like this guy here apparently. This is his answer. So length, numbers, answer is 1 times that. Okay, for I in range. Right is equal reversed. Yeah, that's an interesting answer. That's actually a pretty good answer as well. So we did not try that. I guess we'll try that in a, maybe I'll just try this by myself, but maybe we can just try it right now. I mean, you guys already got the solution. This is the solution here, but I guess we can try it one more way. This is a solution I have not tried before. Alright, so if you guys want to do another way, we can do it another way. So here, okay, so I'm storing n is equal to length of the numbers. Answer is equal to 1 times length of the numbers. So it's going to be, it's just create a bunch of 1s in this array, I guess. And then just go through multiplying everything by 1. For I in range 1 through n, it's going to keep the first element. Answer I is equal to answer I minus 1. Okay, if I times nums I minus 1 times nums I minus 1. Okay, got it. So it's just multiplying everything. So this is basically the LTR chart. LTR, that's what it's doing here. And now we're going to do the right RTL. Okay, so for I in reversed. Okay, that's a good one. I could have done that as well, but you know, I just didn't do that. For I in reverse range, and I guess we don't need the index for this really. So for I in reversed of the range, reverse range. Okay. Answer I is equal to answer I times right. What's right? Right is 1. Okay, and then we're updating the right. Whoa, it's weird how we came up with the same variable name called right. That's something I came up with. I'm just like, oh, let me call this right, and I made it 1, but it wasn't something. I don't think it was something I found online. But yeah, right is equal to that nums I, and then return answer. Sometimes even when we write something like this, what? Oh, answer is equal to that. Sometimes even if we write something like this, we will still get really slow test cases, and our code will still run really slowly, even if we copy the most optimal solution. So we got answer I times right. Answer I equals answer I times right. Reversed I in reverse range to n. Answer I is, dude, doesn't work. Local variable r is referenced before assignment. Okay, so it does work. I just messed up. I didn't set an r right value. Right is equal to 1. So if you guys skip to the end or something, we already solved it. We're just trying another person's solution, and this is the solution. You guys can see how we solved it. Like I walked through how I solved it, and I guess this is the way to do it. Apparently this is faster than the way I did it, even though it is also pretty fast as well. But it's like mine is like 40 milliseconds slower apparently. So this is my solution, and this is their solution. And this is also my solution here, and this is also my solution. Actually, sometimes in my own solution, I was able to get 120 milliseconds. So I was even able to beat this one currently. So my solution does work. I guess you can use whichever one you know better. This one also 120. This one is pretty fast. It's pretty consistently fast, I think. Can you get even lower than this? It's very consistent, like very consistent speeds. 168, so that's even slower than my previous one. So it really depends. Like, I think the way I wrote it was already sufficient. You guys can write it this way as well if you want. If this one makes more sense to you, then you can do it this way. For me, I haven't understood exactly what this code is. I basically just copied it, and I didn't really understand that much. So I got to take a look at it myself, because I'm not really learning that much when I'm talking out loud and trying to learn something. I don't think it works that easily. Anyway, I hope this video was helpful. If you guys liked it, put a like. If you dislike it, put a dislike. Post a comments, any comments, criticism, anything like that down in the comments below. Again, this video was done in real time, so I just went from like beginning to end without any editing or cuts. This is the first time I've been doing this one as well. Well, I already know the solution, but it's the first time I recorded the video for the solution. We'll do one where I don't know the solution yet soon, but for now we're just doing the ones all I know. So thank you guys for watching. If you liked it, put a like. Again, dislike it. If you want to see more videos like this, subscribe, and thank you again guys for watching.